Hi guys, so today we're going to be talking about secants, tangents, and angle measures. Before we get started with our first example, let's define what secant is. Okay? If you've done stuff like trig before, you might have heard of the word secant before. However, this one means something different than that. Okay? So, secant. It is a line that intersects a circle in exactly 2 points, and that is a secant, right? So tangent is if it only touches it in exactly 1 point. Secant is if it touches it in exactly 2 points. Okay, so there you go. Okay, so before we get started with our first example, here is one of our theorems. So if two secants, so you have two secants, note that AB touches it here and here, and CD touches it here and here. So it touches our circle in 2 spots. So two secants here. If they intersect in the interior of a circle, inside of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs. So here, angle 1 is going to be half of AC plus BD. Okay, so angle 2 is going to be half of AD plus BC here. Right? So that takes us to our first example. Okay. So here we have two secant lines, right? Note that this touches it here and here, 2 places, and this one touches it in 2 places here and here. Okay, so finding angle 1. Okay, angle 1 is actually this angle here. Okay. So we know that the arc BC is 30, arc AD is 20. We want to find angle 2. So the way I would do it is I would find angle 1 first. Okay? So angle 1 equals half of the 2 intercepted arcs added. Half of 30 plus 20. 30 plus 20 is 50, and so half of 50 is 25. So angle 1 here is 25. It forms a linear pair with angle 2. So angle 2 and angle 1 will equal 180. And since I know angle 1 is 25, I can just do 180 minus 25, and that gives me 155. So measure of angle 2 is 155 degrees. And that's how I would do it. Okay? The book shows you another way. Okay? And so you can do that way as well. Okay? But for me, this way was easier. The way that the book does it is it knows that angle 2 is half of this arc and this arc. So that would be 360 minus this and this. So then that's the other way to do it. Okay. Okay. So why don't you try CYP1, and then once you're done, come check your answer. Okay, so you should have gotten 115 degrees, whether you chose to use method 1, which I did, or method 2, as in the book, you should still get the same answer. Okay, if you got that right, you can move on to the next example. If not, here is your explanation. Okay, so again, when two secants intersect inside of a circle, this angle here is going to be half of the sum of the intercepted arcs. So angle 2 here is half of this plus this. Okay? And so same thing, angle 1 would be half of this plus this. Okay? So method 2 uses that idea. Method 1 uses us finding angle 2 first and doing a linear pair. Okay, so that's what I did. So angle 2 is half of 55 plus 75, which is a 30, 130. Half of 130 is 65. So 65 plus this should equal 180 because they're a linear pair. Subtract 65 on both sides, so measure of angle 1 is 115. Okay. So what happens if it's a secant and a tangent? So that takes us to our next theorem. Okay. So if a secant, we see that here, right, because it touches it here and here. If a secant and a tangent only intersects one place, intersect at the point of tangent C, then the measure of each angle formed is 1/2 the measure of the intersected arc. So angle ABC here is half of this arc. Angle DBC here is half of this arc. So here, if I have angle ABC here, and arc is AB is 102, and I want to find what this is, first of all, arc AB plus, right, so arc AB plus arc ADB, the major arc, they together form the whole circle, so they should equal 360. Okay? If AB is 102, I can subtract 102 on both sides, right? And then that would give me arc ADB equals 258. Okay? Then ABC, right? This is the secant, this is a tangent. They meet at the point of tangent C, right? Then what we know is that the angle here is going to be half of the arc, and in this case half of angle arc ADB. So that will be half of 258, okay, which will give us 129. And so angle ABC is 129 degrees. Okay? So why don't you try CYP2, and then once you're done, come check the answer. Okay, so for CYP2, angle RQS measures 61 degrees. If you got that right, you can move on to our next example, example 3. If not, here is your explanation. Right? So I know that arc QTS measures 238. Okay? Then this part of the arc, in order to add up to 360, I can find by doing 360 minus 238, which is 122. Okay? Then, to find the angle here, this is the secant, this is the tangent. They meet at the point of tangency, so this angle is going to be half of that arc. So half of 122 is 61, and there you go. Okay, so now we're going to move on to our other theorems. Okay, this is also secant and secant. However, with all of these, the intersections are outside of the circle. Okay, so this is if it's two secants, a secant, and a tangent, or two tangents. Okay, if they intersect in the exterior, the outside of the circle, the measure of the angle formed is 1/2, the bigger one minus the smaller one. Right, so angle A here is half of DE minus BC, the bigger minus the smaller. Okay. Same thing, angle A here is half of the bigger one, DC minus BC. Okay. Same thing here. Intersects outside, it's going to be half of the bigger one, BDC, minus the smaller one, BC. There you go. Okay, so then that takes us to example 3. Okay. So here, we want to find what x is. Okay? So note that they're both secants, right? Touches it twice. Okay, intersects outside, so this angle is going to be half of the difference of the two arcs. So it's going to be 120 minus 50. Right? 120 minus 50 is 70, and half of 70 is 35. So x equals 35. And there you go. Okay. So why don't you try CYP3, and then once you're done, come check your answer. Okay, you should have gotten that y equals 55. If you got that right, you can move on to the next example. If not, here is your explanation. Okay. So again, this is secant and secant intersect outside. So this angle is going to be half of the difference of this one minus this one. So 140 minus 30 is 110. Half of 110 is 55. And so there you go. Okay, moving on to our next example. Okay? So suppose a satellite S orbits above Earth, rotating so that it appears to hover directly over the equator. We want to use this figure to determine the arc measure on the equator visible to the satellite. So we want to find this measure here. Okay. So then what we know is that this angle 10 is going to be 1/2 of this minus this. Okay? However, this here, how do we know what it is? Well, if this is x, this has to be 360 minus x. Right? So this part here is this right here. Can't see it really with my highlighting, but it's this part here. 360 minus x, right? Because if this is x, this has to be 360 minus x. And then minus the other x, minus this x. Okay? So then let's solve for it. This will be 360 minus 2x. Okay? Either you can times the 2 or you can distribute it. It's up to you. So 10 equals 180 minus x. Subtract 180 on both sides. This becomes negative 170 equals negative x times negative 1 on both sides, or divide by negative 1 on both sides. X equals 170. Okay? So that means it's 170 degrees. Okay, so why don't you try CYP4, and then once you're done, come check your answer. Okay, you should have gotten that x equals 205. If you got that right, you can move on to our last example. If not, here is your explanation. Okay. So here, 25, this angle is 1/2 of this minus this. However, we don't know what this is, but in order for this and this to form a circle, it has to total 360. So if this is x, this has to be 360 minus x. So 25 equals 1/2 of x, this, minus this, which is 360 minus x. Distribute the negative, so that becomes negative 360, and then negative x is positive x. I simplified the x and the x to be 2x. I distributed the half. Half of 2x is 1x. Half of negative 360 is negative 180. Add 180 on both sides, and then 205 equals x. And there you go. Okay, now we're moving on to our last example. Okay, so here we want to find x. Okay. So what we know is that here with this angle, it's going to be 45 equals 1/2 of this arc. Okay. What you notice is that WV here is a diameter. So what that means is WRV is a semicircle. So this has to be 180. So that means it would be 180 minus this part, this intercepted arc, minus 10x. Distribute the 1/2. So this is 90 minus 5x. Subtract 90 on both sides. That will be negative 45 equals negative 5x. Divide by negative 5 on both sides. That will give me x equals 9. And there we go. So why don't you try CYP5, and then once you're done, come check your answer. Okay, you should have gotten x equals 20. If you got that, you can get started on your homework. If not, here is your explanation. Okay, so again, this angle is outside. It's going to be x equals half of the difference of these intercepted arcs. So half of 6x minus 2 minus the 78. Negative 2 minus 78 simplifies to negative 80. I distributed the half, so that gave me 3x and negative 40. Subtracted 3x on both sides to move the x's together, so that gave me negative 2x equals negative 40. Divided by negative 2 on both sides, and I got x equals 20. And there you go. That's it for today. Have a great rest of the day. Bye, guys.